Okay, so here the statement is that if it's a triangle with one side squared plus the other side squared equaling the third side squared, if we have that, right, then we can guarantee that it is a right triangle, that one of its angles is a right angle. This is the converse of Pythagorean theorem. Pythagorean theorem says that if it's a right triangle, if right triangle, then you know that a squared plus b squared equals c squared. And we're going to be we have already proven this, so we're going to actually use that, but you'll see why. Now, we want to have it in our minds exactly what we're trying to prove here. So again, we're just given some triangles. So here's a triangle ABC with sides A, side B, and then side C. And what we want to show is knowing that a squared, this side squared, plus this side squared is c squared, that side squared. We want to show, given that fact, that this is indeed a right angle and this is a right triangle. Now, how are we going to do this? The way we're going to do this is we're going to start off with a sort of an axiom. So our axiom is that for any line, right, we can draw a line perpendicular to that line from any point. So at point C, what I'm going to do is I'm going to draw a perpendicular line that's exactly the length of A. So this is the same length as this, and I know that this is a right angle. Now, I could always do that. So again, all I did was I just took some line, right? I could always draw a line that's perpendicular to it, and of course I can make that line of any length I want. In this case, I made it of length A, right? Now, as long as we believe that we can do that, okay, we're in good shape. But there's some things that I want to add to this, right? I know that this is 90 degrees, this angle right here, but I don't know that this is 90 degrees. So it looking like this is a straight line, it looking like this is a straight line here is not guaranteed. You don't know that it doesn't look, something like this maybe. I don't know. Something like this, right? Where this is clearly not a straight line from here to here. Because you don't know that this is 90 degrees yet. You want to prove that fact. So let's go about the next step. So the next step is that you then join A, and let's call this point over here D. Okay? And what you have now is you have, this is of course congruent to itself, AC, that this line, AC, is congruent to itself. And you know that this length here is also A, because that's how I constructed it. What else do I know? Well, I know that this is a right triangle, right? This ACD is a right triangle. And I know from the forward direction of Pythagorean theorem that if it's a right triangle, then the sum of the two legs, one leg squared plus the other leg squared is the hypotenuse squared. This is one leg squared plus the other leg squared is the hypotenuse squared. So in this case, right, this is definitely B. So I know in this one that this side is the same as this, right? So this is A squared plus B squared has to equal this resulting side. Let's call it C prime. That's confusing. Let's do E. I know, since this is a right triangle, right? This one I know is a right triangle by my construction, that A squared plus B squared is E squared. Okay? Because I made this side length A. So I have A squared plus B squared is equal to E squared. But I know in this triangle over here, the original triangle, triangle ABC, I know from my hypothesis that A squared plus B squared equals C squared. Now, these two things are the same. So then this will immediately imply that e squared equals c squared, which implies e is equal to c, and that these two sides are congruent. And now I have that this side is the same as this side. This side is the same as this side. This side by my construction was the same as this one. And of course, this one by reflexive is going to be the same. So then that means that these two triangles are the same. And that forces that this is a right angle. And then you're done. Now you showed that this is a right triangle because it's the same as this right triangle that you constructed. You should convince yourself of this argument.